All right, so sorry, I still have to finish I haven't yet finished your assignment 1 yet, but I think so far so good. It's not too bad. So, but as expected, assignment 1 is supposed to be the easy one. Yeah, so, and this afternoon then we'll actually try to see if we can work your assignment 2 so that everyone can get a comfortable lead. So. Because you still have a couple of days, so but I think today we're going to try to see whether you can get at least really close. So tomorrow it will be less of more of writings and concentrate on that part. Okay, so we can. At first I thought I was going to introduce new device today, but I think we're going to turn today just purely for assignment 2. Okay, so everyone can drive at least the technical part, so you don't have any question. You just drive to where you need to go, and hopefully finish that by the end of your tutorial today. So therefore, tomorrow is always about making a report and things like that. So in that case, you can have a little bit more free time in the tutorial to actually look at the new stuff that we're going to introduce you for potentially for use in assignment 3. So, okay. All right. So today, actually, I thought it would be a good idea. So this is leading up to the next assignment. Is this introduce a new dimension? If you look at Milo, there's this one to talk about collaborations, and the other one talk second half of this talk about authorings. Okay, so that is a more or less more advanced version of the application that you could use. But this is again, this is going to be continue on the foundation of what the unit is, so to give you a sense of what the AIs can do. You want to turn on the light? Oh, the light's on. Is the light switch on the back, or is it control from my end? Okay. Thank you. So now it's hopefully, that's not a sleeping roll on the back. This is at least we can see that you're sleeping. So you're sleeping nonetheless. All right. So so any question before? Just quick question on assignment 2. I think some of you already have question asking me. Is anything? Okay, so I'll see you in a tutorial and see if we can drive that to the finish. Okay, so collaboration here is actually collaboration is quite exists in today. Okay, what you're actually doing now. So to start with a very simple video conferencing, so which is now become a common. Okay, Skype and those type of things. Okay, so so this is a very basic version that we have. So now as a form factor, quality of the network, everything improved the experience. But essentially the actual collaboration size of it is practically the same. You're looking into a screen. Okay. So now in a few that actually overlap with HCI, human computer interactions, called CSCW, so it's computer supported cooperative work. This is really focused, not just HCI is a very big umbrella, and CSCW is actually a subset of that. Okay, this is really aimed for collaborative work. So this one is actually has one term that you should actually pay attention to. This is introduced by Ishii. It's Professor Ishii at MIT. Okay, so he's a big, seen the tangible user interface. Okay, so he would introduce this. It's a term SEAM. Okay, SEAM. Okay, you might have heard the counterpart of this more seamless. Okay, seamless interaction, seamless interface, and those kind of things. But SEAM is the definition is a spatial, temporal, and functional discontinuity. So this is a kind of a break, basically something that you can see the difference between the continuing and discontinuing. Okay, there generally is the two types. Okay, so the two types. First is a functional. Okay, the second one is a cognitive. Okay, so there's quite functional here is between different functional workspace. Okay, functional workspace, and then a cognitive here between different work practice require different understanding of the working models. Okay. So functional themes are something look like this, okay, that you actually have two different functions, okay, application that you're working in a different functional space. As you probably can see here, this is similar to the online collaborative chat at the moment. So someone will look at, this is just showcase that he's on the top right here. You are looking at the screen, and you probably have the experience of having this on Skype. Because the camera, the fact is the cameras are not looking at where you're looking. So therefore, you're always going to see the other side of the teleconference, that the eye gaze is somewhere else. Okay, so they're not looking, even though you try to talk directly to them. And the experience is the same. They are the other way around. Okay, so they also see you looking in a slightly different direction. So in this case, it's generating what the seems. So what that means in the interface design is actually creating a sense that actually a difficulty for people to learn. Okay, this is one of the things that elderly usually have problem with traditional PC interface with the mouse and keyboard, because essentially they are looking, that they try to map between what they were seeing on the screen and what they actually see, what they can feel, what they have to control, which is the keyboard and mouse. Okay, so this is something that fundamentally we need to recognize, because humans actually now, as you know, we have ability to adapt. Okay, adapt really well to interface, but as you're moving along and study more on interface design, you do need to go around and think about what actually you need to make it easier. It's not just to make it happen. Okay, like I always compare this with engineering type of solution. Engineering type of solution oftentimes is make it work, and then the rest of it is a kind of byproduct. Okay, you create a manual so people can follow you 115 steps to finish the same thing. But interface design is really about shortening that part. Okay, and make this seam go away, or reduce it anyway. Mm-hmm. This is one type. Okay, functional. Okay, seam. Second one is cognitive seam. So this is exactly the same task. Okay, so one is a drawing in the old traditional sense on the left, and this one just illustrated it actually a drawing using CAD. Okay, so computer aids and design tools. So that could be a Photoshop, could be those kind of things. So you can see here, which is you look on the surface, it might just look like the two of them produce similar thing. Okay, it might be realistic and something like that. There's difference, but essentially it's a different thing. But from the interface point of view, this is really much a cognitive seam that actually, there's one problem here, the arrows that go between them here is not as easy as sounds. So you might say, oh, the artist here has a skill over 30 years of painting or drawing, and suddenly you introduce new tools and expect him to sit on this chair and perform the same thing. So that is something that interface designer need to be worried about, or need to be concerned and consider very much about this, whether actually it's a cognitive seam, actually how much is it? Okay, so that's why usability, we should go talk about it tomorrow, about how to get things set this up correctly. So these would definitely, you will see that this is a problem. Okay, so people will have some difficulty. So that means the new interface now is really pay attention to this. Okay, how people are actually using it, how people, different target audience, how can they access those? Okay. So hopefully, this probably introduce you with some sense of what that means. So that means when you are talking about the application design, okay, you do need to pay attention to this. It's a tool building for already existing skilled worker. In this case, for example, artists, or actually the application workspaces actually have different function altogether. Okay. So that's so quite a bit of. So the first one here, functional seam. So okay, so this is a meditated from face-to-face conversation. So this is you know what's this idea of technological device that could help mitigate this one. For example, you have a problem with the face-to-face conversation, just like you're looking at a Skype now. Okay, so either camera too low or too high. Okay, how would you solve that? Well, there's no solution quite yet. That's why I've been asking whether you have an idea. So in some way, In some way, what you actually do is, if someone asks me personally, I would say the optical solution is the key. Okay, so you might be looking at a screen, but the screen could have some kind of, just like optical see-through at the moment, you have a beam splitter, so you actually see your eye reflection at the bottom, but you actually don't see anything. So the camera is a capture where you're looking, as a peer you are looking at their face. I mean, in fact, they're just looking at their face. What the camera is captured is actually from behind. Or maybe in the future, who knows, the display and the camera could be actually built on the same thing. My colleagues tried to make this work. I'm not sure how much he had done in Japan. So you might have heard of the technology called live field, okay, live field display. Live field cameras is something of the, usually the cameras are captured just a single light. You have a shutter, you grab it, and that's it. Right? Whether you're out of focus or anything, then it's very hard to post-processing and change that in the material. You can do a Photoshop type of thing, okay? But that is just a manipulation of data. Live field is actually a technology in which you actually capture all the light, okay? The light reflection of all the angles, and you post-processing using that to refocus your image, okay? There's a company trying to make a run for commercially. I don't think they go that far, but essentially that's the technology. There used to be a small device that looked like about this size. It's about $500. But essentially the market doesn't really buy in because essentially the quality image is the same. But the ability, the niche ability is to be able to post-processing at the raw data level what focus of area they want to focus, which is actually is like you go back in time and retaking those photos from the same angle but keep changing the focus. To be at this level or focus on the further away. Okay, so that is actually a display, but then there can be the same technology can be using for to the display and the capture device. Okay, so that is actually still on to be seen. Magically, if we don't have the device on, that one is actually have a live field display on. Okay, so in some way it's a competitive with the HoloLens holographic technology, so we can see whether who will see more clarity. But HoloLens is considered very good at the moment. Okay, so but that is one of the functions. Okay, that actually you have to be mindful. At least at the moment for the unit, you should be mindful that such a seam exists. Okay, that you need to pay attention to. Okay. So this is a loss of gaze. Gaze is actually the eye gaze. Okay, so you can't see. Like I talk to you, then I should see you're looking at me. Instead of talk to you, you're looking at me. But if I have a camera here, I probably see something else, a difference. Okay. Anyone been to actually the physics on the second floor called, I think it's one thing is immersive room lecture theater. Have you been there?
Just like
a big. Yeah, a big wall. Yeah, yes. So that one is quite good. I don't think it's for public viewing, but probably MITS probably hasn't been in there because the room can only fit 20 people. Yeah. So, but essentially it's a half the size like this. A 3 big wall. It's like this size. But what they have here is they have a 3 camera that sit right in the middle. One is in the middle, looks straight. On the left, it looks that way. On the right, it's looking that way, which is actually mapped directly back to the other end of the conference, which it has one in Newnham and one in Catacos, which actually you have 3 screens, so you can see in somewhat has a gaze of where they're looking. If you sit on the right-hand side, you will see, okay, the person actually look to you, although it's not precisely only 3 cameras. Okay, but that is attempt to mitigate those. Okay. So some way, if you actually, that's the second one is a non-verbal cue, which is actually become a more or less of effective, which usually humans, you have not paid attention. If you talk to your friends, then your body language will show, the one with no non-verbal cue, like your hand, your shoulders, and things like that will keep. It depends on if you're getting stuck and then feeling inefficient, ineffective in the way you communicate at the time, then your body language become kind of not moving and then not using. So in the interface area design is actually considered a loss of natural communication skill and the cue. So what that means is that you should try to see whether that can be opened up. Okay, people might think that calling Skype, important thing is that you can hear, you can see. But I think I'm suggesting here is actually, you actually should looking at how they were talking, more how natural they were talking. Okay, so that's why it's important to keep this in mind. Okay. So cognitive here, the key part is really about learning curve. Okay, so that's the cognitive theme which image on the bottom here. So in this case here, the first one, the learning curve. What that means is that if you don't overcome that, what really the real problem is that you will have a skilled worker that able to not work in a new environment. Okay, so that means that like this is just a more clear example, but you're talking about if you develop an interface from build based on 5 years ago, not that long ago, probably not like this. Okay, but the more realistic case that you have a new version, you release the next version. You're not necessarily the first version is very successful. You have a lot of people using it. 5 years later, you release a new version, but then it's so radically changed. So therefore, the fan base or the customer base doesn't transfer because you have a big learning curve going in. So this is something that when you design something like this, you will kind of make a note of this thing. Okay, you try to address this issue or try at least to measure what is actually potential learning curve. Okay. So generally people measure learning curve by simply a measure of time in which they learn. Okay, so that one usability, okay, study, which we'll cover tomorrow. So essentially, you set to a people, to a procedure, have them sit, repeat it for every the same for every participant, and have them sit there and perform certain tasks based on the tool that you want them to look at. And you start to measure how well they perform, how long does it take to perform the task, okay, and that's, in the end, you try to drive it to the learning curve effects. Okay. And of course, it leads to user frustration. Any example that you've seen that your popular software turned to something that's no longer popular? I think this happened a lot in the games, I think, in the game industry. So you have not necessarily the later version is better or more like. And also a more classical example is, for example, is a novel that come out in the print. Okay, it's a very classic Lord of the Rings, for example. You probably know about the story through the movie, right? Most of us will come through the movie, but the older generation are reading this story from the print, for the actual books itself, from the actual authors. Okay. So they have a very, very different view of the movie. In fact, the view of the movie is a more computer graphics. Oh, that's nice, that make believable, but the story are not as good as what they remember from when they're reading a book many years earlier. So that is something that actually, that's a classical example. Okay, you change medium, not necessarily like popular here and you get here. But of course, it doesn't mean that you move a new medium or interface design and you expect the transition to be smooth. You just expect the change of people exception to the technology. Right. So I think if you consider this factor, nothing will so much surprise you in the design. So in some case, you will be able to prevent it or mitigate the effects. Right. So some of these people explored when the VR is the last boom in 20 years ago. So you're looking at different projects. Okay. So this again, Tom Finnis, and then that's his colleagues in Japan. Okay. So what they were experimenting is currently actually this one is quite, even though it's a very old project, but I think it's a good point is that, and what they're doing is actually that professor in Japan is in Japan, okay, and then he's in Seattle, okay. What they're doing is they play ping pong, they play table tennis. They have a holding device that they keep pinging ball back and forth. This is in real time, okay. And then that's a Mount Fuji, I think. It's just to give a sense that that's Japan. And then I think that Japanese professor looked over here, probably see Mount Rainier, which is the symbol of Washington State in Seattle. So probably the same thing. But technology to drive this one at that time was quite massive. Okay, so you're thinking about the network. There's no fiber optic per se at that point. Okay, so what they actually do is that they require to. This is a cardboard. Usually, it's just a normal cardboard. It's not a 3D scan. Okay, however, the movement live, talking live, and also moving of the table tennis hand, the stick is actually live. Okay, so what this is really demonstrating is that ability to collaborate. Okay, in that space, and recognize that actually currently we collaborate to asynchronous. This is an attempt to do a synchronous collaboration. Okay, using in somewhat it's augmented reality. Okay, so this is one of those. But nowadays, I think a lot of these things are changing. Like right now, if they've done this experiment now, they'll probably be in 3D scan. Okay, which is may or may not be necessarily needed, and then. Virtual reality is, on the other hand, provide you a natural spatial cue. So in this case, you will get them to see the body movements, okay, and that's really a collaborative senses. That's what pay attention to. Right now, the technology is pushing toward that. Like the last technology attacking that is Kinect. Okay, Kinect get you the sense of a whole body's gesture. Okay, but this is coming along. So a lot of what Oculus and Facebook really gearing. Every year, this big company will always have they have their own annual developer conference. Like Apple will have one when they launch the iPhone, new iPhone every year. They will always have every year. Google will have one I/O conference, and Microsoft will have similar. They have similar conference too. So this is when they're launching new device. So Facebook's intent to have some sort of a scanning device that allow you to scan yourself inside the virtual space. Okay, and then Facebook I think, is leaning in this direction among the big four. Big four meaning Microsoft, Facebook, and Apple, and Google, because Facebook is building on collaborative, just like the Facebook application now is building on social networking, which is people come together, they share together, essentially they collaborate. Okay. So this is a lesson. So this is a lesson from CSEW. Okay, so for us to get the seamless, okay, seamless has been using a lot. Okay, just the same similar word to intuitive, this interaction, but it's very hard to get. Okay, and then the enhanced reality. This is a second component of it. Okay, because sometimes you can run in these issues that actually, how much should I do for the application if you're going to create an interface? Okay, right now we're looking at the really entry level, but you think about the full potential of the application itself. How much can you do in terms of reality, whether how much is real, how much is not real? Eventually, that's just like the movie that I talked about the other day, Surrogate. It's about reality is changing. But that is well, not yet the scope of our unit, but that is where I think some of these will touch on. One, you can't tell the difference whether the person, right now in Facebook now, there's one phenomenon that people know that actually you can't really sure who you're actually talking to unless you know them beforehand or you know them afterward or something like that. Okay, and that could very well transfer into the virtual environments. When you start to do VR, you start to see each other scanning of the 3D or 3D avatar. We just now start to see the Facebook app Messenger has this funny face, tracking face that you all has experience on. But this one is actually, if it's come live, reality will change. Okay, change that now you will see, but you will no longer. You will always have question whether that's the person you see. Okay. Well, now, immersive virtual reality, and this is what we're sitting on. So this is separate from real world, and that's a spider example I talked about before. And this one is actually a better image than last week. So this is a virtual spider that she saw right here. And this is actually the physical representation of that spider, which is a little tractor there. That's the magnetic tracking. Mm-hmm. So essentially here, I'm not sure the headset is that heavy, but I think she has to have two hands holding it. But essentially, one of her tasks is to try to grab that. She will not see the physical one beforehand, because otherwise it won't be that scary. I think what she will see is that once she put the headset on, she will see this one. Okay, oh, this thing. And assuming if they are completely freak out, then I think that's the end of it. That's the stop of the experiment. But if they kind of somewhat tolerate it a little bit, then the next step is that hunter will ask them to try to grab those virtual spider, okay, which is most participants, even with spider phobia, it basically won't be too concerned. Won't I would say would be not so reluctant to touch it, even though they're afraid of spider, because the spider look not like spider, it just look like some cartoon and game. But then this is where they spook them, is that once they grabbed it, it's kind of like that, they just feel the physical object. So now it doesn't really matter whether this thing has legs, except that it actually has physical presence inside the virtual environment. That's actually spooked them up quite bad, quite significantly. Okay. And that is actually what Hunter, this is Dr. Hunter Hoffman, he's recognized from psychology point of view. And that is actually if you put people inside the real world, inside the immersive environment, in that case, it's not that immersive. It's a field of view, it's about half of what you got, or even less. But if you put in that sense, you can actually get them to think or get them to expose to an area in which actually you can control the environment, which actually you can manipulate the reality. Okay. Which is some of these examples are quite hard to really see in nowadays, because nowadays a lot of money going to the business, so people tend to look for really end products rather than a fundamental use of this technology. Some of these could be very useful for your project. Fundamental thing, you don't need to look for highly graphics, interaction, shooting games, zombie, those kind of things. You kind of look at fundamental component of the project. You will start to see that actually these, just a simple idea, move them out of the world. Okay, then you basically make them believe on something that they're actually supposed to be exposed to. So in this case, it's really just give them, so in this case, they show the example there, so they reduce the conversational cue. Okay. So in this case, when you do the experiment, you can actually capture how they talk. Okay, how they talk, you can transcribe them, you can look at whether that is standard. Okay. Generally, the HCI will compare with comparative case. So in this case here, you have a pair that do in real environments, and then you have a comparative case, which is another pair that doing just face-to-face. Okay, and you start to looking at how they interact, okay, the conversation. So you can kind of gauge it out whether actually it reduces components or not. Mm-hmm. And how about the collaboration in the future? So this one is actually what do you think it look like? How would you expect to collaborate with in the future? Right now you have a lot of this cloud solution. And then which is called as a collaborative sense. Google Drive, it's still called Google Drive. Google Drive and the Drive One, Microsoft, and everything. So you're using shared document, which I think you'll be using for your assignment 3, when you try to put together a document when each one has written a different component of the report. So, but in the future, the collaborative here is still yet to be defined. Mm-hmm. But as you can see here, a lot of these is actually not that far now. Okay, like this one, HoloLens now can use this. Okay, can actually create a single or a finite number of people to use it, but that's require headset. That's a limitation. This is we're talking about a next stage of where actually things will really appear in front of you. Okay. This is what you have now in a 2D form, in the screen, the big screens, and you look through them. But in this case, you are really talking about see them in actually floating. This would be similar to, this is Star Wars, but it's similar to holodeck concept in popular Star Trek series. That would be a similar thing. So essentially, you're really creating content that actually exists in 3D with you. Okay, and you can see the image on the left there, the two characters talking. So in this case here, you really see that it's the eye gaze is really direct. Okay, although technically I don't know how they do. They will be able to do it. This is special effects, of course, because to make a display is one thing. To make the other person to see from his viewpoint is another thing, and that is something that I don't think any researcher is actually dealing with. Okay, because you can put a camera here, okay, but you actually have to know where I'm looking. So that is technically still way out of it. So it might need a different new breakthrough technology to do that. I think live field capture might be one of the potential solutions. Yeah, so, but essentially here we only touch on a few things. Okay, so that this one is a central claim for a lot of AR based community. Okay, that can be used to produce spatial cue. Okay, this one, if you write a research paper before, some of this research said like this is claim in hypothesis, and you should try to hypothesize a situation in which this certain new technology you study or you interest is actually can do certain thing. Okay, before you design the experiment to test whether that's actually the case. Okay, in this case, it says hypothesize that AR can be used to provide a spatial cue, significantly enhanced face-to-face and remote collaboration. Okay, it's very simple claim, simple hypothesis. Okay, so now before that, we can take a look at some of the old one here. So this is collaborative in the old days. When we first have seen the AR, okay, so this is, of course, there are two people working, and you're observing from the third-person point of view. In the last lecture next week, not only are we cover the final, the exam, okay, we also cover the future research. Okay, so some of these now is actually being start to be applied, not this set per se, but have to apply how to design a car, how to design a plane, and those kind of things. So this is a fully collaborative. So in this sense, it's not just about it's happening in front of you, it's now it's just take it further. That's why I like to talk about this now, so it get you form some idea what might be for your assignment 3. Of course, your technically ability for you to working collaborative setup. Working in Unity to have a collaborative capability is not in the scope of this unit. I think it's going to be too far for you to do it, but at least you can project it with a single use into a multiple use. Okay, but you can have at least touch on this one. So you can see here is quite a bit of things that you can look. Okay, so you can work at the independence. Okay, you can actually start to cooperate, because there was some that actually done too many things like collaborative. Okay, if you're forcing that everything has to be collaborative, then essentially here the human being will grow together. You lack an individual, and that is actually not a good for creativity. I think it has to be the talent need to be nurtured at the individual level as well as the group level. So some of these answers are probably still floating out there. So first questions here. Okay, so this is quite a most people don't think about this. They think, we got a seamless interface. So I mean, it's good. But in fact, the big question is whether actually the seamless is actually enhanced performance at all. Because as I mentioned before, a human has ability to overcome and have ability to learn new things. Some people will learn faster, slower. It's up to individual. But essentially, human have the ability to learn that, right? So basically, if you make the system so easy to use, are they improve their understanding? For example, reading books. Okay, there was a controversial finding recently about children, like when they grow up, because in the past, if they are still in high schools, that means they're exposed to digital transformation in the last 10 years. Things changing from learning from purely books into a PDF, to iPad, and that type of thing. Okay, so now they read books through iPad. If they still haven't graduated from high school, most likely that's what their generations are sitting in. And then they are studied to actually try to investigate what is the quality of learning for those students. Okay, whether they actually have ability to learn, they learn faster. There's definitely one thing, the people between two cases, one that actually not use digital too much, okay, like maybe in a school that more public school. Public school will have less of the funding, okay, and private school will have more funding, which is mostly funded by their parents. But there will be more equipped. Each student will have all this high-tech gear for them, okay, and then the public school will have less of that. We'll have a sample of it, but don't have it kind of personalized use. They might not have one iPad for each one, but they can get exposed to iPad as a group. Okay? So that means they can run these kind of things to see whether actually this study was talking about how people learn in a new medium when people scroll through. One of the things they find out, which is probably you already know, that going through PDF rather than looking at the book is much quicker to go through content. Okay, you scroll through quicker, you go to table, you can click hyperlink everywhere. Okay, now the key issue here, how much they actually learn by clicking through it, and that is still very debatable. Okay, I think the interesting here, this generation are now going to come on board in the 5 years, within a few years here, going to university, and that's with understanding what is actually impact to their lifelong learning. Okay. So because they may not have ability to understand things that actually 2 or 3 pages long, because they simply just scroll through that within 2 seconds. And then, but generally people could take time for like 2 weeks to read those 3 pages. So this is something that actually really going to be significant change for the new generation and for the teacher as well. Okay, so some of you who went on to be a teacher, this is definitely going to be a really serious issue, becoming a serious issue. So what that means is that's just a good example of this, is make things easier, more efficient. You do need to understand fully what's impact is that interface to look like. So when you write in the report or you project it in the exam, you need to don't go one way, like, oh, this technology would always do this. We're going to solve this problem. You're always going to be addressing the counterpart of that. What, in your opinion, would be the kickback or the side effect of those technology? What's something that we have to look for? Yes, so, because at the end of the day, we are not making a marketing pitch. We're not making money. So therefore, scientifically or postgraduate-wise, so this unit need to address that side of it. I think the better that. And the subsequent questions are really just more technical design issues. Okay, so what is an AR queue? So in this case, a visual queue, a spatial registration queue, what exactly is more effective. Although that is a little bit tricky questions because it depends on the context in which you're going to be running, what application you're doing. For example, here, I got a few questions on the assignment. Oftentimes I have to respond with it depends on your application, because oftentimes people will just ask without telling me what they're doing. They just ask specific question, which is in the interface design. There's no such a thing as one solution do them all. In fact, that is not a good practice. Okay? So therefore, you do to understand the whole story of what you design, where they're from, why you're doing it, and that's why it would get you to the actual outcome of your design part. Okay. So of course later on here is less and less of the significant part, and you have to kind of solve them one by one. In the end, technology, oftentimes the last one is a tricky bit, okay? Because oftentimes you think, oh, okay, this is where this artist or interaction design will land. Okay, this is the kind of technology we need that has this behavior. If you remember the 7 steps that I have, then by the time you get to the technology step, which is number 3. Then you start to ask what technology can fit into this. Sometimes it doesn't have it. And it's just like example I have a few minutes earlier. How do you reduce or eliminate the gaze, loss of gaze information, the eye contact? Okay. I mean, there's no current technology that do that for saying. So therefore, sometimes these is actually driven by technology driven. Sometimes it's for example, someone produce technology, and then the rest of the consumer market try to figure out what to do, which is, ironically, that's what AR and VR is at the moment. You essentially have a technology, have headset, have everything. That's what the unit is learning. But as I said before last week, killer app is not here. So therefore, technologies are here, but no one really knows what best to use them. So what that means, a lot of big companies, these big four here, is doing here is to bet a lot of money on, but had not yet had income. And that is a big question mark. Okay. Even though they're super rich, but at one point they won't be. They need to have an income return. So killer app is something to fulfill them. So that's why you might have thought I'm joking around the first lecture, first or second lecture. Some of you could turn to be bridging that. If you're bridging those, provide value to make money, a sustainable income for this business, and that's it, and that's what complete the loop. Technology are pushing over in. Even the big four doesn't really know how to make the money, except they can sell you the device, and then they can get some money in, but they're not going to get rich purely just building a device on. They need apps to maintain it. Okay, so they need some kind of application, a need for it. Okay. Right, so just keep your hopes up. All right, so now, collaborative AI, this one is actually being very explored. I think I showed kind of part of this project before. It's basically, it has a map in front of, it's like a build on the same technology, a marker, okay, that actually you put it up. How would you make, it's a card game, okay, the top one is a card game that the girl is playing. So basically a card game recognizes what the card is, and then it's a memory card game. You have to flip two of them to try to match them. Okay, so the thing is that there are many of them on the table. So you force people to wear a couple of these that synchronize together to actually working together. The rule is that you can only open one at a time. So you have to remember them. But the better the game, the better way to play the game is to collaborate with people that kind of in on the same table with you. So for example, you can open this and you can, oh, I'm looking for this one. But then people who already open it, you might have, they will tell you what they already have. So you kind of play a kind of memory share collaborative game. This one is a futuristic illustration of the art of the what AR might look like. Okay, human walk, and then you're actually looking at the content that's apparently look good to be surrounding you with all the pages. Currently, technology can do this. Okay, you can put this around you. Oh, the same thing. This one you can put it inside the Oculus. I have a page information. But if you have to analyze this one, is this thing is really the best way to do it? What is required for this one to work? This is essentially their reading newspaper. The trick here is to consider from the user point of view, because right now this is an illustration from the artist or designer, from outside looking in. But for you to consider that you have to be inside this place and look out whether these kind of configurations work for you. Immediately one thing will come out to you is that the current display here, the AR, will not have this kind of range, the field of view to do it. Only the VR headset now will have. But then would that be useful for you to be reading newspaper in VR? So it's a big question whether actually should you? And if you actually want to do it, what is the main key driver for you to do so? These are the kind of issues that I think you should keep thinking about. There's no set solution per se. There's no wrong equation, wrong answer. Yeah. But this is where oftentimes when there's a lot of hype around it, expectation around it, people tend to kind of push it out and not really realize that actually probably I don't want to read, standing up and reading this thing manually. Okay. Now, face-to-face is very simple. Okay. Face-to-face here, this is a general, so you have a visual that you have three components here. Okay, you have audio, environmental, you have a visual here. Okay, so you can see this is a typical meeting rooms. Okay, that you're sitting, you're looking at an object of interest. In this case, happen to be architecture design. So you can look at what audio, so the people using speech. Okay, you're looking at the gaze, control, visual, gestures. Okay. And you're looking at environmental, okay? So writing, people are doing things on the space, okay? So this is a typical, okay, communication. If you have a group meetings, face-to-face is most likely be like this. Mm-hmm. So people surround a table. It's easy to see each other, so you can tell who has question or who has potentially problem. For example, if you have sit in the meeting, you probably learn how to recognize when people are a bit uncomfortable. Okay, not just because they say they're uncomfortable. They generally be kind of a non-verbal cue, their gesture, those kind of things where it's very difficult to detect without those sense. Okay, so in some sense, that's how we train. Okay, when we are kids, that's how we grew up. We know how to read people body language. Some would read better than the others, but that's how we're born. But then now, when you go into digital age, when all things are suddenly, you grew up as a kid, and then when you grow up, and then it kind of become digital, everything becomes collaborative. And this is one, especially in your generations, is actually the one that coming from those and going to this new, firmly into this generation. So this is require a lot of thinking and what working. Okay, in the new generation now, when they're just 2-3 years old, they're actually going to be born into it. And in some generation, it's like your case, is actually has to transition into it. Okay, so that's a different challenge for a different generation. So in this case, is a really outline is that the task space. Okay, there's two terms: task space and communication space. Okay, the task space here is where actually they're operating the task. Okay, so this is where they actually the work is, where they're looking the object of their communications are. So in this case, is a mock-up of the design of the architecture design. Okay. And then you have this, what they call communication space in green circle. Okay, so that's cover human face, human body, verbal, everything around it. So usually communication is where you can reach them. Okay, so this is the bottom slide here to show you what the normal collaboration look like. Okay, even though I think most likely that's how you will collaborate as well. So this is more or less like this. You're looking at the screen, okay, okay, and then basically people are pointing, and that's what you're actually doing now in the tutorials. So even though you haven't done the A3 start the group work, but you're actually doing this now when you do group learning. Okay, so when we have limited device, and all kinds of people are pointing here, and you notice here. You often have you actually, when you try to work together, the unity together, you realize that your hands and your friend hands sometimes cross over. Sometimes you touch when they're touching. Sometimes like, oh, sorry, yeah, I need to go. Yeah, that's the kind of simple things like this. Is that because you no longer watch the communication space. This one, the task space, is purely on the screen. Okay, but your communication task is actually somewhere else. What this simple diagram, color green communication space and the pink task space here tell you is that there's not, what you actually have is that you have to have them overlap. Okay. In this case, is that since it's not overlap, there's a distinct. This is what they call the seam, functional seam, which actually one is operating on something, and then basically another task is actually sitting on a different space. Okay. And that's technically, in diagram-wise, you require transfer. Okay, how would you know people communicate here, translate into the work here? Because essentially this is the same process. You're sitting entirely on the same process. You try to work out something. Okay. So this one is actually demonstrated at the CGRAPH. Okay, so this is one is CGRAPH is a world premier computer graphic conference. Okay, it's about, I believe it's about 50,000 attendants each year, which is showcase all these graphics, capability, animations, and also this is emerging, which is particularly in that time, 20 years ago, it's about emerging field. Okay, so this is AR with pushing at that time. Okay, so in this case, you can see here multiple people. They actually don't need a screen on the back. Okay, so the screen on the back, they don't really need them. So they're actually looking in a multiple device. All these linked to a one machine, and machine is network. So they know each other. Okay, they're running the same software, and they know each other, what each other doing. So what they're actually doing here is the goal is trying to create a compelling collaborative AR usable by normal people. So in this case, they pick a story. Okay. They pick a story when actually the two characters can interact. Okay, it's similar to using proximity example that we used in the Thai interface in the factory before. Okay, so this one is relatively simple. I think it's the videos. So you can see this is from the view inside. you can see the technology. It's sort of good to show you this old movie in some sense that currently you might have seen a good example in the real world. They're so fancy that gonna take you months to do it. Oh, even if not more than that. But in this case, it show you just a simple technology. You can think about this could be a simple thing that you could do in your program. But what's the underlying message for this thing? And that's what I'm trying to emphasize for all the assignments. It's about getting the underlying message of the design. So why would they do this way? Aliens and the broom, what they're trying to do here. Of course, they were talking while they were working on it. Their goal is trying to matching card game. Okay, matching card is that they try to find two characters, two objects that actually have meaning, supposed to be meaning together. The alien and fly saucer. I think that's what they were looking for. So there you can see his mouth is open, right? Richard May, my colleagues. And now they're starting. So this is very simple stuff, okay, proximity, things like that. But if they're not supposed to, story not supposed to be get together, they're not interact, okay? So in this case here, it's really not, think about it, it's not really about technology sides, but it's really about how to get people. The technology came up, as I told you before, the AR2 kit, it started came out, but this one is really the one that actually showed them, okay, this one can induce people to kind of work together, okay? That's why a lot of a collaborative sense are building on such an early study in this case, which is actually a be good fundamental. As I said before, this one be useful for you to look at it from the sense of you can look at your application development, which could be very primitive, and then compare to what actually the underlying designs look like. Right, so they have quite a number of people coming through, so they have about 3,000. So observations, no problem. Physical objects, okay. Spontaneous collaborations. When they mean spontaneous, it means the tables is just like what you saw there. There's a full headset, I think. So people would kind of wait to get in and then wear them. So that's including kids, okay. So you can see here, kids is actually looking at them. But kids is really not collaborated in that sense. They're just looking at the model. They just like 3D model. Oh, this will look funny, okay. However, they are actually the one that actually start to collaborate with the other kids. Because this is just like when the small kids go to playground, sand pitch, for example. They generally will look at their first tool, put the sand here and doing individual work. But one day comfortable, they start to see the other kids are doing something else, they start to interact. And that's what I think what the design in this space is trying to allow you to kind of mingle and collaborative in this sense. The card game was just a message to get them up over. Okay. Not overly complicated, otherwise nobody knows how to play them. Okay, so 157 say useful. If they could easily play and interact with others. Okay. Improvements mostly technical. Okay, but this problem is no longer the case. Okay, reduced lag at that time is particularly significant. So they only run probably around 10, 15 frames per second. So what that means, they have the speed of what mobile device can do now. So what that means is that they will see that flying saucer is kind of a little bit behind, lagging behind their marker when they move around. But at the same time here, they realize actually, if they stop the marker, then the whole thing shifts. So that means they have a certain sense. That's why I was getting it. Even though technology at the time is not really as ready as we are now, people can still feel it because people can compensate for a lot of these shortcomings. That's why the big question is still whether all these advanced things, whether it's bring anything extra to it. And the key to that is the application. If the application doesn't bring anything, it's just going to look fancy, and that's it. And it's not going to sustain. People won't be using them because there's no need for them. Okay. All right, so before we run the case studies, let's take a 10 minutes break. So see you at 10 after 10. So. Right, so we'll continue. Now, this is going to set up some case study, which is one of the studies we had done, okay, my colleague has done. So this is just give you a flavor of what if you go into a research in this area in HCI, this is a simple study that you can use, okay, that you can kind of see as a case study. So in this case here is that they just want to look at the effects of what outcome of collaboration using AR. Okay, that's just a very simple questions. Okay, and so therefore, as I said before in the beginning, some early on, is that you have comparative case. That's oftentimes a classical study platform. Okay, you comparative. So in this case, we have 3 cases of study that we compare. So one is face-to-face, okay, one is using augmented reality, AR technology, and one is using projection, just like a screen like what we have here at a lecture. And then the task itself is basically the task itself really have to fit, try to see, make, just like the card memory game that we show at CCRAF. It basically has a foundation that allow them to facilitate, allow them to kind of start to collaborate, have the reason to collaborate. Okay, so in this case, it's a puzzle game. Okay, which is essentially a urban design. There's 9 buildings, but each building has certain regulation, like certain building cannot be next to the church and those kind of things. So they need to read those rules and try to use those tools to kind of help them guide with where the building should go. Okay, so they have total of 9 buildings to satisfy 10 rules in 7 minutes. So this is kind of giving them kind of a question and task. So this is operated by 2 people. Okay, so we have total of 12 pairs of students coming through. So we have first one is actually a moving model. Okay, so this is like they have the rules, 10 rules that they're reading. So there's a church, there's a government building, and so this is quite a center of in a small city. Okay, so now I think those space between them is a road. So I think in this case is how they design. Typically, if you have a clean slate like this, then you can actually have but the certain rules that the church should not be next to, let's say, a nightclub next to the building, commercial. So and then basically that's why you kind of running through them. But the idea here is that the 2 of them know there's 10 rules they need, regulation rules that they need to follow, and then they kind of go through this different combination to see what works. Okay, so this is one case, face-to-face. The other case here, they're using AR. Okay, so you can see here they put in AR goggles. Okay, so they start to see, of course, each of these with different character. That means each of them representing a unique building. Okay, so in that case, they will see a different building in here. Okay, so the same thing. Instead of you see the real mock-up model, you actually see a virtual representation of that. And the last one here is comparative case here, is that you're actually projecting all this to the screen, and just like a big monitor, and the 2 of you sit next to each other and looking at the screen and try to, pointing to it, moving to it, and you have a small device, okay, which is a tracking. So this one actually allow you to do like a 3D mouse, to pointing in space. Okay. So, and that's what the screen is showing. Okay, so in this case, you can use the mouse, click, drag, drop to see what. But the idea here is that this is really testing interface module instead of their knowledge. Their knowledge is really in their head. They have to run to that rules, 10 rules that they have to comply. Okay. So in this case here, I then go back to the basic space separation task. So you can see here communication space here, the one on the left, okay, when you're looking straight at them, okay. So that would be in the first 2 cases, AR case and the face-to-face case is the one on the left. So when the task is actually in front of you and you have ability to communicate within the space. And of course with projector, they're similar to the big monitor before, so when you're looking inside, from outside looking inside the working space. So your communication space stays separate, kind of less connected, less overlap with the task space. Okay. So now, just go to the outcome. So they run this study, 12 pairs, so they each complete the test. They look at this one. Okay. So this is what they were using into a DITEC expression. This one is DITEC is something like, look at that one. That's the word that they use. Like they don't use like, okay, look at the marks. They're just looking at that one and they point, or they use the word, and people were getting the understanding. And you can see here the level number of percentage of people use of all the communication they use, about a quarter between the face-to-face FTF and the AR. It's about 20-25%. Okay, there are significant drop in the projection, in the projector, not projection. Projector here, the drop is below 15. So what that means is that it shows that actually this is when people are not using that ad effectively. Okay, so in that case here is that, for example, if you look at the tutorial now and you say, oh, why don't you click that? Right? If the Unity screen is actually floating in front of you and you can see them, then you can tell. You can have a more chance of telling. But the current mode, when you look inside into the monitor, you would avoid using that kind of term, which is a detect. So in that case, you are actually more or less using, why don't you click at this button that has a name, okay, the inspector and those kind of things more specific. So you realize that those detect that you usually use is actually less and less, okay? Because you realize that actually, once you start using it naturally at the beginning, your partner, your collaborator may not understand it. So once you realize that, you're adapting. So you're not using it. So you're using less and less. Okay, so that is a side effect. That is the effect they observe. This one is a pick and move feedback. Okay, they will ask people whether they actually what they feel, ease of interaction, whether how picking the building, putting the table on, move the building from one corner to the other. How easy is this? Is asked them to rank. Okay, so of all the scores. So in the highest score on a vertical, the easiest. So that means the thing is good, easy. Okay, so in this case here is the most that you can see here. The picking a building, extremely difficult. But the notice here is that the yellow is AR and the face-to-face in purple. They are all similar range. Okay, pick and move. They are similar. Okay, the one that actually much lower is a projector. So in this case, it's actually they find that it's harder to use. Okay, not individual experience because they're working as a pair. So in this case, it would mean they're actually having harder time to communicate. Okay, inside the projector mode. Okay. So this is a very obvious study, obvious outcome that very easy to quite understanding. So in this case, generally when you analyze a paper, you will say, okay, you're not saying that the AR and the face-to-face are the same. You actually say you can't tell the difference. And that's more technical terms. So there will be statistical significant analysis that you have to run if you want to publish a paper. Okay. So, but this one is obvious. Projector is the most difficult method. Okay. So we also have run a quantitative case. Says in HCI, there are two types of study: qualitative and quantitative. Qualitative and quantitative. Okay, so qualitative is like quality. Okay, so that's oftentimes required, including subjective opinion. But quantitative here is the one that actually you measure performance, you capture the numeric performance. In this case, is that actually can measure the finish time. Okay. They're given the 7 minutes, so therefore that's the limit. So, but they don't have to use all 7 minutes. Mm-hmm. So that they find out the first finding. So AR collaboration is slower than the face-to-face. Okay, which is actually from the previous one. It sounds like you would expect it from the previous chart as well. They look like face-to-face and ARs are kind of all. No difference. In many couple regards, they look the same. But then the first finding here is actually showcase that actually, if you're looking at analysis in performance in terms of completion time, so the turnout AR collaboration is slower. Why do you think it's slower? No, synchronization, latency is one, yes, but it's not. I think it probably affects some, yeah, but I don't think it's the main reason. I think one of the main reasons here is that we have to look from within when people are wearing this AR. It's not like AR headset at the time was heavy, so make them move their head slower. But that was one thing that actually quite obvious standoff parameters. But let me cover the rest of this. Okay. So in terms of communication, okay, pointing, picking, gestures, behavior same in AR and face-to-face. Okay. This is what you would expect because they actually have the same posture. They're standing here, they're looking at the plate, so every gesture, the way they move is similar. Okay. Unlike the one that you sit next to each other and look at the screen, and that is the way they interact with the difference. Okay. So I think this one we already covered. Didactic speech, okay, same. Subjective opinions, so face-to-face, easy to work together and understand. Okay. This is one thing that when you write a lot of in a report, this unit, oftentimes you tend to champion AR and VR, overly champion them. The fact that you think AR and VR is the best. Okay. Oftentimes that is actually the weakness, when in fact all VR and AR do, hoping to do in a lot of cases, a lot of applications, is to try to be as good as face-to-face. There's the same thing with no experience as good as a real one. Yeah, so when you say VR and AR is better, so that means you're talking about artificial experience is actually better than a real experience. Then you have to be very, very confirmed, very, very firm that actually you got it. Because most of the case, you don't actually, it's just a substitute experience. Okay. That's why if you're going to go and then try to say it's better than face-to-face, you have almost better to say there's no face-to-face that exists in that particular context. Therefore, this is creating this, like simulation for earthquake. You can't really just want to simulate something that disaster, so you just have to create it in space. So that's one thing. But that's obvious come out from this, okay? Because if the face-to-face is not the easiest thing to work with, you will suspect the pair is actually in a fight. They don't actually like each other. Because I think that so the researcher would, this is almost like what they're planning a comparative case so that they know precisely that this is going to come out. Okay? They're just looking for whether the other ones should come out near, how near they are. So interaction in AR is easier than projection, similar to face-to-face. So all this is looking from different point. Okay. So the interview comments, they did make a semi-structured interview. Okay. So the subject is focused on tasks, just easy to see and gaze. Okay. For the face-to-face case, for projection display, basically they say interaction is difficult. They rate 8 of 14. 8 of 14 people are saying rate is difficult. Okay. So that's more than half of it. So that's not mouse-like because essentially it's a 3D object tracking. So essentially they will be moving their hand up in the air a little bit. Okay. And then invasion of space here, even though the term is a bit strong, but essentially a conflict, basically collide space. The same thing with the example I used before in the tutorial. When you try to grab a mouse, someone had tried to grab the same mouse, and then your hands touching, things like that. So that is become a space overlapping. Okay. But this is what the AR was working mostly. It's working solo together. Even though they're standing the same way, the other partner is standing the opposite, the same with the face-to-face. But in this case, it's really obvious for them that they're working practically solo because they have this effect I highlight in red. It's called tunnel visions. In this case, it's like you go into a tunnel. When you go into the tunnel, like train go into the tunnel, you just see that tube, nothing else. Right? And that would be the effect of what AR is, and it still is today. Because essentially here, when you go in there, you don't see anything else. In that case, it uses a video see-through. So basically, video, we're just seeing that part only. They won't see this part. Okay, so therefore, you'll be looking like you're looking at the video, but video doesn't capture all this frame. They just capture this one. So essentially, you'll be kind of try to find something, and your field of view is really small. But that's because they use video see-through. Okay, you have to understand those are part that are driving this effect. With the HoloLens, you will have less effect of that because you don't have, it's an optical see-through, so you don't actually have the video relay of the real world. You see the whole thing. Yeah. But you still have some effect of the tunnel because your augmented field is only limited to about less than 40 degree field of view. Okay. So the AR biggest limits is lack of real visions. Okay, so in this case, even the optical see-through you will see in HoloLens tomorrow, you still don't, even though you see, your peripheral view is still visible because it's essentially a sunglass. Okay? You can see through them. However, your augmentations are missing because it's only done in the virtual frame, a holographic display, so just at the center of your view. So therefore, anything you want to superimpose, it's got to be here. So that means whatever you do, you have to move yourself so that the center is always at the center. Your center view is actually at the center of the AR objects. Okay? So it's affect the way your head is moving. Okay? So this is a subtle thing that you should recognize. Okay? That actually is impact how people behave. So this is just a summary. Okay, so I think the first top is partly a perceptual task. Okay, user field AR is different than face-to-face. Okay, so and this is what hypothesis is that AR is as good as face-to-face. Okay, so but now their study showed is the participant, the 14 participant, the 12 participant is feel different. Okay. They feel different. So what that means is that it just provide them enough evidence to a further study. Okay, they could not conclude that actually it's better, same, but they know it's different. Okay, so I think, yeah. So I think the last one here is a kind of key. Okay, so that we need to design AR interface. Okay, that don't reduce perceptual cue. Okay, while keeping ease of interaction. So in this case, it really allow you to see how to keep the perceptual cue, which is actually start to get impact by this the impact of study. So you don't see as much. You see the window of augmentations. If the virtual object is big, then basically you practically slide through them because you only see that much at a time. So you end up having head moving like that. Okay. So this is a lot of them driven by, some of these are driven by technical limitation. Okay. But some of these is really understanding what technology is. That's why I keep coming back to assignments. It's about merging those. Okay, that's why you won't be able to overcome the technical components in the tutorial. So therefore, that's why I put a lot of emphasis in the report, that you need to be able to see through it. Okay, whether you see that little tiny thing that usually is kind of under that. So I was looking for that. The standard one is very obvious. This application can do this, focus on that. That's usually guarantee. It will land you in somewhere in the distinction point. Okay. If you're going to get HD, you need to nail that further into it. But actually, there's a pro and con and everything going further. And that's, to me, I read many hundreds of them, thousands of them already, so I kind of know what angles you're going to get. Okay. So make sure if you just hit solidly, you go along the way. But unique idea oftentimes would actually come from the idea the student has. Okay. So try to keep me, provide me some enlightenment in your study, your report. All right, so the next one is remote collaboration. This is when things are getting a little tricky. So in this case here, I'm not sure this one is linked. Yeah. So this one is actually spin the same technology here. You can see marker everywhere. Okay, so this one is actually augmented reality help. You can tell me at the end of the video whether you actually like it. It's in Japanese, so you might not understand it. Yeah. So essentially, he learned to build this, pretend to be machine part. It's essentially a Lego. And you can see the model of constructing, assembling things popping up. So he was kind of looking at it, and he tried to imitate those, just like a 3D manual. Okay. And then now, he's now calling on a system. Okay. And then a system will pop up. And then our assistant is actually start talking to them. I can show it. So that's Dr. Kato. This is his co-inventor of the AR toolkit, the little marker. So that's what I think is pitching as something of what collaborative AR might look like, remote collaborations look like. What it does is that actually it doesn't really pop up, just a pop-up. It's actually, you can have ability to move them around. So for example, you put that help desk, move them around with fit. And this is actually available in the HoloLens now when you're Skyping into one of these HoloLens devices. You actually see a sky face floating here. You can move the sky face somewhere on the wall, and it will stay there. So you look that way, then you won't see this one. You come back, and then the person stay here. So it gives you a bit of a sense of, I think it's, by itself is actually not as useful, just one-on-one Skype or teleoperating. However, this one particularly could be enhanced quite significantly or see the effect, a positive effect more if you have multiple, more than just one-to-one like this. You have 1 to, let's say, 4 people. And then suddenly, instead of you just hear their voice, they're coming, okay, you actually have them situated inside environment around you. It's like 4 people around you. And you have the audios that sync with the spatial direction to that. So when someone turns, then you recognize. Because that's how human makes sense of multiple channels of input will come in. But right now, we kind of squeeze that thing into it one. And we just make sense, try to remember who is who we're talking. So that one is actually using the spatial ability to position in space of AR to help you distinguish between multiple sources of input. But this is only one-to-one, so it's not as strong. So this one done at the UniSA, okay, so this one is actually using a collaborative sense that actually this is the view of outdoor. UniSA, Bruce Thomas, my colleague, he's actually working in this space, outdoor AR. He's the one that built many years ago called, you know the old-time games called Quake? Quake games, the shooting zombie, before zombie. Yeah, you go into a dungeon and you keep shooting things. So he built what they call AR Quake, okay, which is at that time is anything put AR on it. So AR Quake here, it's essentially is just like the Columbia University one with the library backpack, big backpack. They're the same thing, the big backpack.
Jumping a lot? Like,
yeah,
I remember that.
There was that's an AR Quake. So basically, you're walking around campus and shooting this monster. But that is actually technically there's a lot of engineering work to that. But the concept here is really how people interacting. If you look at their track, their publication, if you realize describing a technical component because it's kind of so difficult at the time. And also another set of application from that group is about what do you learn from. Not just carry a big backpack. And what do you learn from it? Well, why would you interact inside an environment better, right? So, or anything different. This one is another spin on top of that word. So this is the view of people that you will see in AR Quake, which you actually see walking in real-world environments. So this is a screen capture of that. So they walk around, they have an annotation, this is a building here, it's just like a campus tour. And then suddenly there's a gigantic hand pointing in front and then say, hey, you're supposed to go here. Yeah? But in fact, that hand is actually that person. Okay, in the control room, another room that connected to the outdoor unit. And he has this, look like some kind of a washing machine that he actually point his finger into it. Yes. In that case, in this case here, that's a map. You probably can see where there's a projector projecting into that space, the little white area. Okay, which essentially, if I can remember, essentially it's not a cream or washing machine. It's actually a projection of the UniSA campus map, top view. So in that case here, his hand, he simply pointed to the building in which he wanted the outdoor guy to go. And the outdoor guy was just looking for that big giant hand. Okay, and that's when I think at the end they found the hand. Okay, there's a hand. There was a couple of navigation cue that's before he get here, because remember you were walking building. There was supposed to be on the high-date building, so this guy keep walking. And then that one is kind of a way to communicate them. Okay, so this is that just explore this very long. This is a start to be seriously looking at by military. Okay. I shouldn't say too much about that, but essentially here, what military is looking for is communication between the land soldier, people who walk on the foot, and people who fly the plane. Not necessarily they want to meet mid-air, but they need to coordinate effort to target a target on the ground, which is actually you have a two different view. From the airplane, you have GPS coordinate system that you can pinpoint, but you can't tell precisely which one. Okay, but the ground can know. Yeah? Then how to communicate between the person on the ground, like this one, and the person who actually in control room that could be flying off, fly a drone, those kind of things. So there's a work in that space already here. Okay. This one, I showed you before already, right? No?
Show you an exciting new technology that could fundamentally change the way that people will.
Let me give you a prep. This one is HoloLens built with. This is a team out Microsoft Research in Cambridge, the research unit. They did a lot of work. They did original work for them is Connect, okay, Connect Fusion. So using Connect device that capture your posture. To use that, Connect essentially. Anyone heard of Connect before? The Connect. Yeah, yes. Microsoft Connect essentially look like a big bar. You might actually seen some of those attaching to it. But essentially, the Connect here is scanning the depth of the environment. So it's not just capture color, red, green, and blue. It's actually color the depth. It's detecting the depth. So that means if they take a photo of that, of the depth image, they will see that this object, this pixel is closer to me. That pixel is further away from me. So when you print it out, you see a kind of a structure map of the environment. So you see a kind of contour of mesh of the environment in that case. So their original work is called Connect Fusion, started 5 years ago. But now their recent work, the last couple of years, they've been focusing using HoloLens as a way to drive their scanning technology. Okay.
Imagine being able to virtually teleport from one space to another in real time. Hey, Sergio, how does it feel like to be holoported?
It feels great to be holoported.
So Sergio has to wear his HoloLens device, and I'm going to wear mine. We can see each other in full 3D in real time. We can interact and communicate as if we're co-present. Sergio, can you walk around my space? Can you walk behind this chair? So we're doing everything.
The image on the bottom left, that's the image that he sees through his HoloLens. That's, by the way, that's a HoloLens that he wears. Okay? And the person who in another room on the left is also wearing another HoloLens. So he see his view, that's his live view on the top left. You can see that, okay? So now they're kind of in a chair environment in some case. And you see the scanned version of both of them on the back wall screen. You see that? The little silver man here? That's both of them inside the space. So the trick for this one is that they scan you inside the 3D, which is nothing new. But what that's new about this one is that it's done in real time. Real time. They're not post-processing, they're not special effects that spend months after in post-production. Okay, this one is live. And now then they try to interact and then showcase further.
To give the impression that Sergio and I are present in the same space. Sergio, let's just do a high five. That's great. Thank you, Sergio. We call this technology holoportation. Now, to make all this happen, we've had to create a new type of 3D capture technology. I'm surrounded by these 3D cameras that we've developed in our team. Each of them is capturing me from a separate viewpoint, and we're fusing this data together to create a temporally consistent model, as you can see reconstructed live behind me. Now, the camera that's filming me has a HoloLens tracking system attached, and this allows us to take these 3D models and composite them in real time into the real world, as you can see here. And that gives you a sense of the fidelity of the reconstructions that we can achieve. Once we have these reconstructions...
No, there's a couple of things here, maybe I should... There's a scanning technology. They introduced two technology in here, scanning technology and the AR technology. They're not the same thing. AR is not doing scanning. AR is simply a display, a 3D display that displays the scanning. What happens if you got the scanning, but you don't actually have a display, you have a fixed model. They keep moving around, but you don't know where they are. But for them to have the scan, which is a silver guy, that guy in silver, to be superimposed on him, they need to know the direction, the tracking of the HoloLens, of the camera that's filming, because the camera keep moving around. You see, that's what the AR is. There's two parts, the scanning and there's the AR.
We can texture them. We can then compress the data and transmit the data over to the other side. Over on the other side, a user wearing a HoloLens can see these remote participants live in their space as if they're co-present. And that's what we're showing you picture in picture. Now imagine using this type of capture technology to connect with family members who are thousands of miles away. And that's exactly what we're going to demonstrate to you right now. My daughter is stood in a similar capture rig somewhere else in our lab. And she's going to holoport into my space, and I'm going to interact with her wearing my HoloLens.
Hi, Bob, I miss you.
Hey, Lillian, I miss you too.
You coming home?
I'm coming home very soon. Let me get out of your way. Hey, Lillian, you can only hear me, you can't see me, but what are these toys?
I have toys to show you. This one, his name is Elmo.
Elmo?
And he can sing.
You can sing, wow. And what about the other one?
Note that
The other
he
one
see her
is
in 3D though.
called
This her is
Tina.
restructured
I
3D.
didn't like it 'cause
It's
it
not just a two-plate like
has
what you see
different
here. They
stuff.
actually see them in 3D.
That's so cool. So Lilia, can you climb up on this chair that's behind you?
Okay.
Yeah, climb up. Be very careful. Now I'm going to count to 3 and I want you to jump. 1, 2, 3, jump! That was so cool. Oh, let me get out of your way again.
I like you so much.
I love you too.
You know that why he need to get out of her way?
Because otherwise you like get issues with the meshing.
Yeah.
The shield can't be embedded on top of him and won't actually go behind him.
Well, in some way, you will try to avoid that because then when you're filming it, it would look like she walked into him. Yeah, so, and that will actually tell, oh, that's not real. So in fact, it's actually, the technical reason is because they can't do it yet, so they just want to move it out. And he just plays like he wants to play with his family.
Bye-bye.
It looks like there's still a lot of predefined scripting and things in this. Like you can see
Now in that example,
areas
we were
in which have
demonstrating.
been taped up, specific predefined markers and things of both.
They have to calibrate the space. Yeah, they have to calibrate the space beforehand. The scanning is done live though. They actually run, you can walk, any one of us can walk in there, can scan it right real time. However, the scanning system, you probably only see the 2 posts in front of you. There's actually 4 of them, 1, 2 behind. So the whole thing was scanning in real time. So, so that means there's a lot of calibration for this to really just happen. Yes, so AI is just coming
Live
at the
3D
end.
capture. But our system is capable of another thing. We can actually record and play back that entire session. Now this is almost like reversing through time. And if I wear my HoloLens device, it's almost like walking into a living memory that I can...
So this is one of the things that I think AR might be. So now you have a medium, so photo, videos, and all whatnot, but this could be the next one. So you were seeing this in a movie like Star Trek before, when they play out the memories and things like that. So this is actually, we observing this is, I think it's an undersell, but in fact, you actually can walk around. So this could be in the future when you try to preserve the memory of the loved ones. So this could be the effect that allow you not just to watch static, you actually can be inside it. And it's changing in some of the movie industry as well. Try to imagine you're part of the story in a movie, but you don't actually have to follow the director. You can be looking around inside the set. However, the transition is still hectic in terms of, okay, if the main character run that way, but you still want to hear it's what happened, then you might actually know the story. And that's the call of the non-linear storytelling. So.
See for another pair of eyes from all these different perspectives. And because this is 3D content, we can miniaturize it onto this coffee table and experience it in a more convenient manner. And this becomes a magical way of experiencing these live captured memories. Now imagine being able to teleport to any place with anyone at any time. And that's what holoportation is all about. Thank you for watching.
Now his team gonna come up. Hopefully, Facebook will have something. Facebook introduced something that, of course, this kind of setup probably not for consumer use. So I think the big company will try to nail this thing down into a much more practical solution when everyone can use at home, but probably not require any hardware. All right, so I think we'll time us up. So we'll continue tomorrow. Okay.